just continuing on, we just talked about this diagram here, turning the turbines. So essentially all energy sources use the same schematic of the turbine and the generator and the transmission, just a different energy source goes in. I know it's crazy, but actually 51% of our electricity in Ontario is thermonuclear. So I'd like you to start thinking about the advantages and disadvantages of perhaps using nuclear energy from your knowledge, watching the news and reading and studying, etc. Here's our last example for heat. Okay, so geothermal energy. This is probably one of my favorites because it's so natural and found in our environment. I think it's actually really cool. So what this is it's actually naturally hot water deep in the Earth's crust. So it's the hot rocks in the Earth's crust that warm the water and actually create steam on the surface. So as you can probably guess, we're going to use that steam to power the turbine. You got it. I think you're getting the idea here. So in Canada, I would say British Columbia is definitely one of our geothermal energy sources. They're usually best found in places that have volcanic activity, but those are a little bit hard to find nowadays. Because this has to do with naturally existing in the Earth's crust, this is a renewable resource. Okay, so we've reached our last category. So just to recap, we've done water and we've done heat, and now we're going to take a look at some other energy sources that are just kind of in their own category. So first things first, we've got solar energy. And just as the title gives us, you can probably guess that we're dealing with the sun. Sun is a very, very powerful tool, and it actually helps us a lot in generating electricity. So solar cells, so these guys right over here, they're made using silicon. And it's these layers, so these glass panels here, they have different layers. They've got a layer of silicon, glass, anti-reflective coatings, and metals, all in different layers, and that's exposed to sunlight. And when that sunlight comes through, they actually heat a liquid that's found beneath, and that creates the steam. Okay, so that energy that's taken from the sun to heat these panels, that's going to heat the water underneath because it's going to get so hot, and that is going to in turn turn into steam, and it's going to drive the turbines. So take a look at my image right here. I'm going to zoom in for you. So as you can see here are the generators, the panels that are heating the liquid, and the steam is going to come out of this one rod to power that turbine, to power the generator, and to continue on its pathway. Another fun renewable resource, and this is actually becoming more and more prevalent in Ontario, and I'm sure you've seen this, is actually using wind energy. So quite obviously it's renewable. It's a resource of the earth. And this one's probably the most simple to explain. It's actually the wind spinning the blades of the turbine, and the actual machine, the actual windmill, is the generator. So those blades spinning connect directly to the turbine. However, you need a certain speed of wind to power these types of machines, and the value for you is actually approximately 10 kilometers per hour. That's the minimum speed of wind required to generate the power. So in Ontario, we probably get enough wind 20% of the time. So wind is great, but it's not going to give us all the energy that we need. Okay, I think we've reached our final source here, so I hope you're catching up with your table here. You can always go back and forth, pause the video, rewatch, etc. Here's tidal energy, and this actually uses the gravitational pull of the moon. And what it is it's not anything to do with the solar system, it's the gravitational pull of the moon that actually moves the tide, moves the waves. Okay, so it actually measures, gives power of the tide coming in and the tide coming out. And those forces drive the turbine and make it spin. So because once again, we're using water in this case, not the force of water per se, just like hydroelectricity, but more so it's the using physics, the pull of the moon to use tide coming in and tide going out. Okay, let's take a minute to recap.
Here's a question for you. How many people does it take to turn on a light bulb? The answer seems simple. Just walk into a dark room, flip a switch, and instantly you can see, right? Well, the truth is there's a lot more to generating and delivering electrical power than you've probably imagined. Hi, I'm Lee Patrick Sullivan with Energy Now, and this Energy 101 video explains the system used to generate electricity. And it also explains what it really takes to turn on a light bulb. In order to understand energy, we first need to start at the source, literally. Mother Nature provides the natural resource we use to generate power. From natural gas to coal, ocean tides to mountain winds, the energy we need to create electricity must first be mined, harnessed, or collected from the earth. Some of these resources are finite, including fossil fuels like coal and oil, but others are unlimited, like solar or wind power. But a lump of coal or a strong breeze alone won't create the power that turns on your light. For every energy source, a chemical or mechanical process is required to turn it into usable electricity. Every day, researchers work to find innovative ways to use our limited resources, process raw materials, harness renewables more efficiently, and find entirely new energy sources. Today, the majority of America's electricity comes from thermal power plants. Fuels like coal, natural gas, biomass, and uranium are used to heat water until it produces steam, which powers a turbine and generates electricity. That steam turns propeller-like blades around a rotor inside the turbine. This turning rotor connects to a main shaft which spins magnets with a coil inside a generator. It's the generator inside a turbine that converts mechanical energy into electric energy and creates electricity. Steam is an efficient method of producing electricity because the water can be recycled and reused as it changes back and forth between liquid and gaseous states. Transporting electricity from the power plant to your home is an entirely different process.
Perfect. So we're just going to stop that there because we just wanted to review the energy sources. So that's just a recap on how those generators get those energy sources. Now that brings us to the end of the lesson. Now, if you missed any information, because you need to bring this table completed to me tomorrow, okay, you can either rewatch the video if you liked hearing my lovely voice, or you can get the same information on pages 477 to 481, and there are all the energy sources laid out for you, okay? So I just wanted to reiterate that you are going to bring this completed chart, okay? I need you to take a look at page 482 and 483 and come up with some advantages and disadvantages for each energy source because you will be debating tomorrow, okay? So remember, if you missed anything, make sure you got that chart filled out. Go to the textbook or rewatch the video. Thank you guys so much for your attention, and I will see you in class tomorrow.